Hi everyone, we're Group 95 from the Machine Learning course and this is our project proposal. Our team members are Arvind Raza, Anand Halwan, Bryan Kim, Eunice Kim, and Sapan Patel. In New York City, ride-sharing apps like Uber and Lyft are more popular than taxis because of the price visibility. For Uber and Lyft, the ride price fluctuates and is calculated before the ride starts. On the other hand, taxi fares have a flat rate that's calculated at the end of the ride. We believe that predicting the taxi fare before the trip helps riders know when taxis are the cheaper option and helps them decide which service to call. For this project, we chose to look at the 2013 New York City taxi data, which contains both fare and trip data. Some of the important categories are the pickup and drop-off date and time, the payment type, the fare and tip, the passenger count, the trip time and distance, and the latitude-longitude coordinates. Currently, deep neural network models are being used to predict New York City taxi fares, and we hope to add to this work with our own project. With this in mind, we defined our own problem. There are many factors that decide the fare for a taxi ride, like the time of day, distance, and location, and while these rates are standardized, they're still complicated to understand when you're not familiar with all the various charges and rates. As such, it is very difficult to know how much you'll pay for the ride before you enter. We view predicting taxi fares as a regression problem. With a given set of features, we want to estimate the final price of the trip. Some features we plan to look at are the start-end coordinates, time of day, and the date, and we could do additional processing of these features to extract more relevant information, such as the month, day of the week, and pickup hour. Also, principal component analysis will be useful in reducing features while maintaining the information. Some models we're looking at for data analysis are linear regression, random forest regression, and neural networks, since these models work well with the regression problems. Finally, we plan to train each model using loss functions such as the root mean squared error. Conducting exploratory data analysis will help us understand the features better. We plan to plot probability density functions to better understand the spread of data and spot outliers. Some of these include the frequency of cab rides based on the hour of the day and the number of passengers. Also, a correlation matrix will help us understand how to group the features together. We're expecting a high positive correlation between pickup and drop-off coordinates because certain locations are more popular for taxi rides, and distance and fare amounts because the distance is used to calculate the fare amount. Finally, by calculating the mean absolute error to characterize each model's accuracy, we expect to see an accuracy of around 70 to 90% since these results are typical of regression-based cab fare prediction models. These are the sources we used, and thank you for listening.